So let us work. Good morning. Is my voice audible?
Sir.
Okay, right. So a few more problems on linear transformation. Find the linear transformation f from R2 to R2
Yes,
such
sir.
that. Okay, right. Find the linear transformation f from R2 to R2 such that f of 1 comma 0 is 1 1 and f of 0 comma 1 is minus 1 comma 2. So here you have to find the linear transformation from V2 of R to V2 of R such that f of 1 0 instead of t here f is given. So f of 1 comma 0 is 1 comma 1 and f of 0 comma 1 is minus 1 comma 2. Remember, it's a mapping from V2 of R, that is two-dimensional vector space, to another two-dimensional vector space. So domain and the codomain are same. So the vectors 1 0 and 0 1, that forms the basis of R2. Remember, they are the standard basis vectors like E1 and E2. What is E1? That is 1 comma 0 and E2 is 0 comma 1. Remember, they are the standard basis of two-dimensional vector space V2 of R. So 1 comma 0 and 0 comma 1, that forms the basis of R2. Take any arbitrary vector belonging to the domain. Let x comma y belongs to R2. So let x comma y belongs to R2. Then x comma y can be written as x into 1 0 plus y into 0 1. This is because if once you simplify the right hand side here, you can write that as x plus y, x plus y into 0 and x into 0 plus y into 1. Therefore, it is x comma y. So x comma y, if you add the corresponding components in the right hand side, you will get x comma y. So therefore, x comma y can be expressed in terms of the basis unit vectors of V2 of R, that is x into 1 comma 0 plus y into 0 comma 1. Now define a linear transformation f from V2 of R to V2 of R or R2 to R2 by f of x comma y equals x into f of 1 comma 0 plus y into f of 0 comma 1. Because if you operate f on x comma y, if you operate f on x comma y, you will get x into f of 1 0 plus y into f of 0 1. This is by the definition of linear transformation. So because it is linear, you have used t of alpha plus beta is t of alpha plus t of beta, and t of c alpha is c into t of alpha. So using that definition, you can write x into f of 1 0 plus y into f of 0 1. But you know the value of f of 1 comma 0 that is given in the problem itself. So what is f of 1 comma 0? That is 1 1. Substitute the value of f of 1 comma 0, that is 1 comma 1, and substitute the value of f of 0 comma 1. What is f of 0 comma 1? It is minus 1 comma 2. Now simplify the corresponding components, that is add the corresponding components. X into 1 plus y into minus 1, that is x minus 5. X into 1 plus y into 2, that is x plus 2y. So the linear transformation is f of x comma y equals x minus y comma x plus 2y for every x comma y belonging to the domain R2, that is. So the required linear transformation is f of x comma y equals x minus y comma x plus 2y. This is another way of doing. In the last class, we have used t of E1 and t of E2, but this is easier as I feel. Next, example 2. Find the linear transformation f from R2 to R2 such that f of 1 comma 1 is 0 comma 1, f of minus 1 comma 1 is 3 comma 2. So here 1 comma 1 and minus 1 comma 1, they are the basis of R2, that is. Let alpha be equal to x comma y belongs to R2 be arbitrary. Now x comma y can be written as C1 into 1 comma 1 plus C2 into minus 1 comma 1. X comma y can be written as C1 into 1 comma 1 plus C2 into minus 1 comma 1. Our aim is to find the scalars of C1 and C2 belonging to the field of real numbers. Because we do not know what are the values of C1 and C2. This you cannot write this by trial and error method. In the last problem, in the previous problem, it was easier because we have unit vectors 1, 0 and 0, 1. You can easily write x comma y as x into 1, 0 plus y into 0, 1. But here the basis vectors are different. That is 1 comma 1 and minus 1 comma 1. We do not know C1 and C2 here. So therefore, you have to find the scalars of C1 and C2 by solving the equations that we shall see now. So x comma y can be written as C1 into 1 comma 1 plus C2 into minus 1 comma 1. That is x comma y equals, add the corresponding components. You will get C1 into 1 plus C2 into minus 1. That is C1 minus C2. That is C1 minus C2, comma. Next, second component addition is C1 plus C2. So C1 plus C2. So two vectors are equal if and only if the corresponding components are equal. So if once you equate the corresponding components, you will get C1 minus C2 equals x and C1 plus C2 equals y. C1 minus C2 equals x and C1 plus C2 equals y. So therefore, you have to solve these two equations. How do you solve this? Add those two equations. Add the first equation C1 minus C2 equals x and the second equation C1 plus C2 equals y. If once you add that, C2 gets cancelled. So after cancellation of C2, what you will get is 2C1 equals x plus y. 2C1 equals x plus y. If 2C1 is x plus y, what is C1? C1 is x plus y divided by 2. Next, if you know the value of C1, substitute in the first equation or second equation, you will get to C2. Or else you subtract the first equation, the second equation from first equation. If you subtract, you will get C2 value, that is C2 equals y minus x divided by 2. If you subtract, C1 gets cancelled, you will get C2 value. So this is by solving those two equations. How do you solve the simultaneous equation C1, C2 equals x and C1 plus C2 equals y? You will add and you will subtract and then you will find C1 and also you will find C2. If once you know the values of C1 and C2, substitute here, that is x comma y equals C1 value x plus y divided by 2, C2 value is y minus x by 2. So if you substitute, you will get x comma y equals x plus y divided by 2 and into 1 comma 1 and y minus C2 value is y minus x divided by 2 minus 1 comma 1. Now operate f on both sides because our linear transformation is f from R2 to R2 here. So operate f on both sides. You will get f of xy equals x plus y by 2 into f of 1, 1 because f of C alpha is C into f of alpha. That is property of the linear transformation. So using the definition of the linear transformation, you can write x plus y divided by 2 is a scalar here. They are C1 and C2 because they are scalars. If you have f of C alpha, that scalar can be taken outside, you will get a C into f of alpha. So that is x plus y divided by 2 into f of 1 comma 1 plus y minus x by 2 into f of minus 1 comma 1. This is obtained by operating t on both sides. But you know the value of f of 1 comma 1 that is given in the problem itself. What is the value of f of 1 comma 1? That is 0 comma 1. What is the value of f of minus 1 comma 1? That is 3 comma 2. Substitute those values. We will get f of 1 comma 1 value given, that is in the problem itself it is 0 comma 1 and f of minus 1 value is also given, that is its value is given to be 3 comma 2. Now add the corresponding components. X plus y by 2 into 0, that is 0, plus y minus x by 2 into 3. So I will get 3 into y minus x divided by 2. Second component addition is x plus y divided by 2 plus 2 into y minus x divided by 2. So what we will get is 1 by 2 into 3y minus x here and here 3 by 2 into y minus x. This is the required linear transformation from R2 to R2 such that the mapping is defined by f of 1 comma 1 is 0 comma 1 and f of minus 1 comma 1 is 3 comma 2. Let us work one more problem. Find the linear transformation T from R2 to R3. Remember here R2 is 2-dimensional, R3 is 3-dimensional. So domain is 2-dimensional and codomain is 3-dimensional. How the mapping is defined? T of 1 comma 1. T of 1 comma 1 is 0 comma 1 comma 2 because it is 3-dimensional codomain. T of minus 1 comma 1 is 2 comma 1 comma 0. What we have to find? You have to find the linear transformation from R2 to R3. Now, 1 comma 1 and minus 1 comma 1, they are the basis vectors of R2. Remember, according to the theorem, domain elements ಏನು ಕೊಟ್ಟಿರ್ತಾರೆ ಅದು ಬೇಸಿಸ್ ಆಗಬೇಕು ಆಗಿರುತ್ತೆ. So 1 comma 1 and minus 1 comma 1 is a basis of R2. Next, let us directly go to this. Let alpha be equal to x comma y. X comma y ಅನ್ನು ಹೇಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀರಾ? C1 into 1 comma 1 basis vectors ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬೇಕು. What are the basis vectors? 1 comma 1 and minus 1 comma 1. So I can write this as C1 into 1 comma 1 plus C2 into minus 1 comma 1. Now, the previous problem, what we have is C1 into 1 comma 1, C2 into minus 1 comma 1 equals x comma y. Same as this here also same. So therefore, solving those two equations, you have got there C1 value, that is x plus y by 2, C2 value y minus x by 2. So therefore, substitute to C1, C2 value there. So finally, you will get. Now operate t on both sides. Operate t on both sides. So t of x comma y equals x plus y by 2 into t of 1, 1 plus y minus x by 2 into t of minus 1 comma 1. What is the value of t of 1, 1 given there? T of 1 comma 1 in the problem, it's given to be 0 comma 1 comma 2. So, and t of minus 1 comma 1 value is given to be 2 comma 1 comma 0. Substitute those values there. You will get t of 1 comma 1 value is 0 comma 1 comma 2 given in the problem. And t of minus 1 comma 1 value is given, that is 2 comma 1 comma 0. What we have to do is we have to add the corresponding components. First component wise, if you add this, you will get x plus y by 2 into 0 plus y minus x by 2 into 2, 2 cancels, you will get y minus x. Second component is x plus y into 1 divided by 2 plus y minus x into 1 divided by 2. So what we have is x and minus x cancels. Y plus y is 2y divided by 2, therefore it is y. Third component addition, similarly, you will get x plus y by 2 into 2. 2 cancels. So you will get x plus y. So the linear transformation t of x comma y is y minus x comma y comma x plus y. So these are all 5 marks problems. It will be asked in the examination in similar fashion. Next. Is there a linear map T from R2 to R2 for which T of 2 comma 2 is 4 comma minus 6, T of 5 comma 5 is 2 comma minus 3. The meaning of this problem is T of 2 comma 2 4 comma minus 6 and T of 5 comma 5 2 comma minus 3 ಆ ತರಹ ಮ್ಯಾಪಿಂಗ್ ಇರುವಂತಹ ಲೀನಿಯರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಇದೆಯಾ? ಮೊದಲನೇದು ಆ ತರಹದ ಮ್ಯಾಪಿಂಗ್ ಇದೆಯಾ? ಎರಡನೇದು ಅದು ಲೀನಿಯರ್ ಆಗಿದೆಯಾ? ಲೀನಿಯರ್ ಅಂದ್ರೆ it should satisfy 2 conditions. T of alpha plus beta is T of alpha plus T of beta. T of C alpha is C into T of alpha. ಆ ತರಹದ ಲೀನಿಯರ್ ಮ್ಯಾಪಿಂಗ್ ಇದೆಯಾ ಅಂತ. ಯಾವಾಗ ಇದ್ದೇ ಇರುತ್ತೆ ಇದು ಅಂದ್ರೆ ಡೊಮೈನ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರೋ ವೆಕ್ಟರ್ಸ್ ಬೇಸಿಸ್ ಆದ್ರೆ ಇದ್ದೇ ಇರುತ್ತೆ. ಯಾವುದು ಡೊಮೈನ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರೋ ವೆಕ್ಟರ್ 2, 2 ಮತ್ತೊಂದು 5, 5. ಅದೆರಡು ಬೇಸಿಸ್ ಆಗಿದ್ರು ಮಾತ್ರ ಇರುತ್ತೆ. ಅದು ಬೇಸಿಸ್ ಹೌದೋ ಅಲ್ವೋ ಅಂತ ಚೆಕ್ ಮಾಡಿಬಿಟ್ರೆ ನಿಮ್ಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಲೀನಿಯರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಇರಲ್ಲ ಅಂತ. ಇಲ್ಲಿ ಬೇಸಿಸ್ ಆಗದೆ ಹೋದ್ರೆ ಇರಲ್ಲ. ಬೇಸಿಸ್ ಆಗಿದ್ರೆ ಇರುತ್ತೆ ಅಲ್ವಾ? ಆ ಥಿಯರಂ ಪ್ರಕಾರ ಏನು ಹೇಳಿ, ಇಫ್ β1, β2 to βm is the basis of U, alpha n, alpha 2, alpha m or the m vectors of V, then there exists a unique linear transformation T from U to V such that T of beta I equals alpha I ಅಂತ ಆ ಥಿಯರಂ ಇದೆಯಲ್ಲ, ಆ ಥಿಯರಂ ಇರಬೇಕಾದ್ರೆ ಡೊಮೈನ್ ಅಲ್ಲಿರೋ ಕೊಟ್ಟಿರೋ ವೆಕ್ಟರ್ಸ್ β1, β2 to βm ಅದೇನಾಗಿರ್ಬೇಕು, ಬೇಸಿಸ್ ಆಗಬೇಕು ಅಂತಿದೆ. ಹಾಗಿದ್ರೆ ಇಲ್ಲಿ 2, 2, 5, 5 ಬೇಸಿಸ್ ಆದ್ರೂ ಮಾತ್ರ ಲೀನಿಯರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಆಗಕ್ ಸಾಧ್ಯ ಇದೆ. ನೋಡೋಣ ಬರುತ್ತಾ ಇಲ್ವಾ ಅಂತ ಅಲ್ವಾ? ಸೊ ದಿ ವೆಕ್ಟರ್ಸ್ 2, 2, 5, 5 are linearly dependent. ಯಾಕದು ಲೀನಿಯರ್ಲಿ ಡಿಪೆಂಡೆಂಟ್ ನೋಡಿ, 5, 5 ಅನ್ನ 5/2, 2, 2 ಅಂತ ಬರೀಬಹುದು. 5, 5 ಅನ್ನ 5/2 into 2, 2. ಹೌದಾ? ಚೆಕ್ ಮಾಡೋಣ. ಈ 2 ಕಾಮನ್ ತೆಗೆದುಬಿಡಿ, ಇಲ್ಲಿ ಆ 2, 2 ಕ್ಯಾನ್ಸಲ್ ಆದ್ರೆ 5 into 1, 1 ಆಯ್ತು. 5, 5 ಕರೆಕ್ಟ್ ಇದೆ. ಅಂದ್ರೆ ಅರ್ಥ ಏನು, one vector 5, 5 is expressed as the linear combination of the preceding vectors. One theorem is, if some one of the vectors can be expressed as the linear combination of the preceding vectors, then the set of vectors is linearly dependent anta one theorem ಇದೆ. ಸೊ ಅಲ್ಲಿಗೆ ಇದು ಲೀನಿಯರ್ ಕಾಂಬಿನೇಷನ್ ನಲ್ಲಿ ಮುಂದಿನ ವೆಕ್ಟರ್ನ ಹಿಂದಿನ ವೆಕ್ಟರ್ನ ಲೀನಿಯರ್ ಕಾಂಬಿನೇಷನ್ ಅಲ್ಲಿ ಬರೆಯಕ್ಕೆ ಬರುತ್ತೆ ಅಂದ್ರೆ ಅವಾಗ ಏನಾಯ್ತು, ಲೀನಿಯರ್ಲಿ ಡಿಪೆಂಡೆಂಟ್ ಆಯ್ತು. ಲೀನಿಯರ್ಲಿ ಡಿಪೆಂಡೆಂಟ್ ಆಗಿರೋದು ಯಾವಾಗಲೂ ಬೇಸಿಸ್ ಆಗಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ಯಾಕೆಂದ್ರೆ ಬೇಸಿಸ್ಸಿನ ಡೆಫಿನೇಷನ್ ಪ್ರಕಾರ ಲೀನಿಯರ್ಲಿ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಗಿರ್ಬೇಕು, ಆಮೇಲೆ ಲೀನಿಯರ್ ಸ್ಪ್ಯಾನ್ ಆಗಿರ್ಬೇಕು. ಲೀನಿಯರ್ ಯಾವ್ದಾದ್ರು ಒಂದು ಅದರಲ್ಲಿ ಫೇಲ್ ಆದ್ರೂ ಇಟ್ ಕೆನಾಟ್ ಬಿ ಎ ಬೇಸಿಸ್. ಇಲ್ಲಿ ಮೊದಲನೇದೇ ಫೇಲ್ ಆಗುತ್ತೆ. ಯಾವುದು? ಲೀನಿಯರ್ಲಿ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಗಿರ್ಬೇಕು ಬೇಸಿಸ್ ಅನ್ನೋದಿದೆಯಲ್ಲ. ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋ ಡೊಮೈನ್ ಅಲ್ಲಿ 2 ವೆಕ್ಟರ್ಸ್ 2, 2, 5, 5 ಅದು ಲೀನಿಯರ್ಲಿ ಇಂಡಿಪೆಂಡೆಂಟೇ ಅಲ್ಲ. ಯಾಕೆ ಲೀನಿಯರ್ಲಿ ಇಂಡಿಪೆಂಡೆಂಟ್ ಅಲ್ಲ ಅಂದ್ರೆ, you have expressed the last vector as the preceding linear combination of the preceding vector ಅಂದಾಗ ಅದೇನರ್ಥ, ಲೀನಿಯರ್ಲಿ ಡಿಪೆಂಡೆಂಟ್ ಅಂತ. ಅಲ್ಲಿಗೆ ಇದು ಆಕ್ಚುಯಲಿ ಈ ತರ ಲೀನಿಯರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಇರಕ್ ಸಾಧ್ಯ ಇಲ್ಲ. ನೋಡೋಣ, ಸಪೋಸ್ ಇಟ್ ಈಸ್ ಲೀನಿಯರ್, ಇವೆಲ್ಲ ಹೊರತಾಗಿ ಅದು ಲೀನಿಯರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಆಗಿದೆ ಅಂತಾನೆ ತಿಳ್ಕೊಳ್ಳೋಣ. ಅವಾಗ ಏನಾಗುತ್ತೆ ನೋಡೋಣ. T of 5, 5 can be written as T of 5/2, 2, 2. ಹೌದಾ? ಚೆಕ್ ಮಾಡೋಣ. 2, 2 ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. 2, 2 ಕಾಮನ್ ತೆಗೆದಾಗ 2 ಕ್ಯಾನ್ಸಲ್ ಆಗಿ 5 into 1, 1 ಆಯ್ತು. 1, 1 ಅಂದ್ರೆ 5, 5 ಕರೆಕ್ಟ್ ಇದೆ. ನೆಕ್ಸ್ಟ್, ಲೀನಿಯರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಆಗಿದ್ದಿದ್ರೆ T of C ಆಲ್ಫಾ ಇದ್ರೆ, C ಅಂದ್ರೆ ಇಲ್ಲಿ 5/2 ಇದೆ, ಆಲ್ಫಾ ಅಂದ್ರೆ 2/2 ಇದೆ. C ಅಂದ್ರೆ 5/2 ಇದೆ, ಆಲ್ಫಾ ಅಂದ್ರೆ 2/2 ಇದೆ. T of C ಆಲ್ಫಾ ಇದ್ರೆ ಲೀನಿಯರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಡೆಫಿನೇಷನ್ ಪ್ರಕಾರ C into T of ಆಲ್ಫಾ ಆಗ್ಬೇಕು ಅಲ್ವಾ? ಅಂದ್ರೆ 5/2 into T of 2, 2 ಆಗ್ಬೇಕು. ಯಾಕೆ? ಲೀನಿಯರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಆಗಿದ್ರೆ. ರಿಮೆಂಬರ್, ವಿ ಆರ್ ಇನ್ ರೇ ವರ್ಲ್ಡ್. ಸೊ 5/2 into T of 2, 2 ಅಂತ ಬರೀಬಹುದು. This is 5/2 into, what is T of 2, 2? T of 2, 2 is, that is 4, -6. T of 2, 2 is 4, -6. ಇಲ್ಲೊಂದು ಕಾಮ ಬಿಟ್ಟೋಗಿದೆ, ಸರಿ ಮಾಡ್ತಾರೆ. 4, -6. ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡೋಣ. ಈಗ 5/2 ನ ಇನ್ಸೈಡ್ ತಗೊಳ್ಳೋಣ. 5/2 ನ ಇನ್ಸೈಡ್ ತಗೊಂಡಾಗ 2, 2 ಆಗಿ 5, 2, 10 ಆಯ್ತು. 5/2 ಇಲ್ಲಿ ಇನ್ಸೈಡ್ ತಗೊಂಡಾಗ ಇಲ್ಲಿ -15 ಆಯ್ತು. ಅಲ್ಲಿಗೆ T of 5, 5 ಅನ್ನೋದು 10, -15 ಆಯ್ತು. T of 5, 5 ಅನ್ನೋದು 10, -15 ಆಯ್ತು. ಆದ್ರೆ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದೆ T of 5, 5 ಕೊಟ್ಟಿದೆ ಎಷ್ಟು? 2, -3. ಆದ್ರೆ ನಮಗ್ ಬಂದಿರೋ ಆನ್ಸರ್ ಏನು? ಇಟ್ ಈಸ್ 10, -15. ಸಾಧ್ಯ ಇದೆಯಾ? ಕೊಟ್ಟಿರೋದಕ್ಕೆ ವಿರುದ್ಧವಾಗಿದೆಯಲ್ಲ. ಕೊಟ್ಟಿದ್ದೇನಿದೆ? T of 5, 5 is 2, -3 ಇದೆ. ಬಟ್ ನಮಗ್ ಬಂದಿರೋದು T of 5, 5 10, -15 ಬಂದಿದೆ. ಯಾಕೆ ಈ ಅನಾಹುತ ಆಯ್ತು ಅಂದ್ರೆ, ನಾವು ಇದು ಲೀನಿಯರ್ ಅಂತ ತಗೊಂಡಿದ್ವಿ. ಲೀನಿಯರ್ ತಗೊಳ್ಳೋಕೆ ನಮ್ಗೆ ಅವಕಾಶ ಇಲ್ಲ. ಯಾಕಿಲ್ಲ? ಅದು ಲೀನಿಯರ್ ಆಗಿದ್ದಿದ್ರೆ ಲೀನಿಯರ್ಲಿ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಗ್ಬೇಕಾಗಿತ್ತು. ಲೀನಿಯರ್ಲಿ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಗ್ಲಿಲ್ಲ. ಲೀನಿಯರ್ಲಿ ಡಿಪೆಂಡೆಂಟ್ ಆಗಿದ್ರಿಂದ ಗಿವನ್ ಸೆಟ್ ಆಫ್ ವೆಕ್ಟರ್ಸ್ ಇನ್ ದಿ ಡೊಮೈನ್, ಗಿವನ್ ಸೆಟ್ ಆಫ್ ವೆಕ್ಟರ್ಸ್ ಅಂದ್ರೆ ಯಾವುದು? 2, 2 and 5, 5 ಅದು ಬೇಸಿಸ್ಸೇ ಅಲ್ಲ. ಅದು ಬೇಸಿಸ್ ಅಲ್ಲದೆ ಇರೋದ್ರಿಂದ such a linear transformation ಅಥವಾ linear map. ಯಾಕೆ ಇದಕ್ಕೆ linear map ಅಂತ ಹೇಳಿದ್ರು ಅಂದ್ರೆ ಡೊಮೈನ್ ಮತ್ತು ಕೋಡೊಮೈನ್ ಎರಡು ಒಂದೇ ಇರೋದ್ರಿಂದ linear map ಅಂತ ಹೇಳಿ. So such a linear map cannot exist. So with given data ಅಂದ್ರೆ ಯಾವುದು t of 2, 2, 4, -6 ಇರಬೇಕು, t of 5, 5 is 2, -3 ಇರಬೇಕು. ಆ ರೀತಿ ಇರುವಂತಹ linear transformation ಅಸ್ತಿತ್ವದಲ್ಲೇ ಇಲ್ಲ ಅನ್ನೋದು ಇಲ್ಲಿ ತಾತ್ಪರ್ಯ. So therefore what we have is such a linear transformation does not exist. Why it doesn't exist? This is because just because 2, 2, 5, 5 is not a basis. Why it is not a basis? Because it is not linearly dependent. It is just linearly dependent. Okay, let us take another problem. So do you have any doubts? Do you have any doubts? ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ? ಯಾರು ಒಬ್ರು ಹೇಳಿ ಸಾಕು. Yes. Indudar, do you have any doubt? Is my voice audible? Okay, right. So let us go to the next problem. Let M of R, M is representing matrices, remember, over the field of real numbers. M of R be the vector space of all 2 by 2 matrices. The set M ಅಲ್ಲಿ ಏನಿದೆ ಅಂದ್ರೆ ಎಲ್ಲ 2 by 2 matrices ಇದೆ. And B is a fixed non-zero element, fixed matrix. B is a fixed 2 by 2 matrix of M of R. Show that the mapping T from the vector space M of R under matrix space, to matrix M of R defined by T of A equals AB minus BA for every A belonging to MR is a linear map. The problem is a linear map idagide antannadu linear transformation problem bitre idu find the linear transformation problem alla, adrinda ee problem agide. Next, example 6. This problem was asked in the examination. If T from R2 to R2 andre V2 of R is a linear transformation, linear map kuda agbodu yakandre domain matte codomain eradu same ide, such that T of 1, 0 is -1, 1. T of 1, 0 equals 1, 1. Minus alla equals 1, 1. And T of 0, 1 is -1, 2. Show that T maps the square with vertices 0, 0, 1, 0, 1, 1, 0, 1 into a parallelogram. The meaning of this is, we have a linear transformation from R2 to R2 defined by T of 1, 0 is 1, 1, 1, and T of 0, 1 is -1, 2. This is how the linear transformation is defined. You have to find the general linear transformation. That is, you have to find T of xy form. Next, after finding the linear transformation, what we have to prove is the mapping of that function T, or that linear transformation T, which maps the vertices of the square. A square has 4 vertices. So what are the 4 vertices given there? It is 0, 0, 1, 0, 1, 1, and 0, 1. What we have to prove is, you have to find the image of all those vertices, and you have to join all those vertices after finding the image, and you have to show that under that linear transformation, the image will be a parallelogram, so that the square maps onto a parallelogram. Remember, this is an application of linear transformation. Suddenly a question will arise in your mind that what is the use of linear transformation in due course? So this problem illustrates the application of linear transformation in different fields. Of course, here it is a mapping from square to a parallelogram. That is, you can shear a square into a parallelogram. Let's go through the solution. What is given in the data? Data here it is t of 1 comma 0. Its image is 1 comma 1. T of 0 comma 1 is minus 1 comma 2. So this is the image set which is being given. Under that linear transformation, the vector, two-dimensional vector 1 comma 0 is mapped around to 1 comma 1 and 0 comma 1 is mapped around to minus 1 comma 2. For that, to find the linear transformation, it suffices to take a two-dimensional vector, so that is x comma y belonging to R2. Then what you can write x comma y as, you can write x comma y as x into 1 0 plus y into 0 1. You can check this. You have done this earlier. X comma y, not t of xy, remember. I am speaking of only x comma y. X comma y can be written as x into 1 comma 0 plus y into 0 comma 1. If you are having any doubt, you can check. You can simplify the right hand side, that is x into 1 comma 0 plus y into 0 comma 1. You will get x comma y, that is addition of the corresponding components. Now operate a t on both sides, you will get the t of x comma y equals t of x into 1 0 plus y into 0 1. This is something like t of alpha plus beta. T of alpha plus beta is what? T of alpha plus t of beta. But if you have t of c alpha, you will get c into t of alpha. So here x and y are scalars, remember. So therefore you can write this as x into t of 1 0 plus y into t of 0 1. This is by definition of linear transformation. Further, you can write that as x into, what is t of 1 comma 0? T of 1 comma 0 given there in the problem itself. That is 1 comma 1. Substitute the value of t of 0 comma 1, that is minus 1 comma 2. Add the corresponding components now, that is x minus y comma x plus 2y. So this is addition of the corresponding components. So now t from R2 to R2, you have got the linear transformation now. Now you can find the images. How do you find the image? What are all the things given there? 0 comma 0 is one vertex of the square. 1 comma 0 is another vertex. 1 comma 1 is another vertex. 0 comma 1 is another vertex of square, remember, not parallelogram. They are all the vertices of a square. Now we have to find the image of 0 comma 0, that is a t of 0 comma 0, t of 1 comma 0, t of 1 comma 1, t of 0 comma 1. First we shall find the images. T of 0 comma 0 is nothing but by putting x equals 0 and y equals 0 in the linear transformation. If you put x equals 0 and y equals 0 here in the right hand side, you will get 0 comma 0. Call that vertex as A. And t of 1 comma 0, t of 1 comma 0 is by putting x equals 1 and y equals 0. You will get x equals 1 and y equals 0 in the right hand side. What you will get? 1 comma 1. T of 1 1. When x is 1, y is 1, you will get 0 comma 3. Call that vertex as C. T of 0 comma 1 is similarly when x is 0, put x equals 0 here, y equals 1 here, you will get minus 1 comma 2. Call that vertex as D. Not on here the image set. What is this image set? Image set is shown in the figure. In the figure, it has 4 vertices. What are the 4 vertices? A, B, C, D. Remember 0 0 1 0 1 1 0 1 ಅದನ್ನ ಟ್ರೇಸ್ ಮಾಡಿ ನೋಡಿ ಅದು ಸ್ಕ್ವೇರ್ ಆಗುತ್ತೆ. ಯಾವುದು 0 comma 0 1 comma 0 1 comma 1 0 comma 1. If once you trace this or if once you plot this, you will get a square. ಅದು ಒಂದು ಸ್ಕ್ವೇರ್ ಆಗುತ್ತೆ. ಆದರೆ ಅದರ ಇಮೇಜ್ ಇದೆಯಲ್ಲ, ಇಮೇಜ್ ಏನು ಬಂದಿದೆ? ABCD ಬಂದಿದೆ. ABCD ಅಂದ್ರೆ A ಅಂದ್ರೆ 0 comma 0, B ಅಂದ್ರೆ 1 comma 1, C ಅಂದ್ರೆ 0 comma 3, minus 1 comma D. So that is shown in the figure. 0 comma 0 ಅಂದ್ರೆ origin. ಅದರಿಂದ origin is A. Next B, that is in the first quadrant, 1, 1, 0, 3, that is C, that lies on y-axis because the x coordinate is 0. And that is second quadrant, D there, that is -1, 2. Why it is in the second quadrant? Because x is negative, y is positive agidrinda. X is -1 and y is 2. Adrinda second quadrant that is being traced and that is being depicted in the figure. Next, what we have to prove now? This figure is a parallelogram. By looking at the figure, we can easily say, yes, it is a parallelogram. But that is not. We have to prove. Mathematically, nothing is accepted without proof. Only axioms are accepted without proof. Axioms or postulates are accepted without proof. But all other things we cannot accept. So therefore, without proof, we cannot accept these things. So we should give an analytical approach or analytical proof to show that it is a parallelogram. In your high school classes, you have studied. What have you studied? Something is a parallelogram. How do you prove this? The easy way of proving something is a parallelogram is the diagonals bisect each other. You have two diagonals here. What are the two diagonals? It is AC is one diagonal and DB or BD is another diagonal. What we have to prove is these two diagonals bisect each other. Name itself suggests bisect. Bi means two. It divides that into two parts. In other words, something divides into two parts is nothing but that point is a midpoint. So I have to show that the midpoint of AC, midpoint of the diagonal AC in that figure, and the midpoint of the diagonal BD in that figure, they are same. If they are equal, then it implies the diagonals bisect each other. The diagonals bisect each other. That in turn will imply that the figure is a parallelogram. Okay, let us find the midpoint. You know how to find the midpoint AC. Midpoint AC. How do you find the midpoint using analytical geometry? That is x1 plus x2 divided by 2, y1 plus y2 divided by 2. That is addition of the x coordinate divided by 2. Next, addition of the y coordinate divided by 2. That gives you the midpoint. That's midpoint formula in first year PUC analytical geometry. So if once I add this, so therefore, what are the coordinates of A? 0, 0. 0 plus 0 divided by 2, that is 0. 0 plus 3 divided by 2, 0 plus 3, because second coordinate is 0 for A. 0 plus 3 divided by 2, that is 0, 3 by 2. This is midpoint of AC, that is this point of intersection, remember. Next, midpoints of DB, midpoint of DB. Again, you have to add corresponding x component. -1 plus 1 divided by 2, what you will get? 0. 2 plus 1 divided by 2, that is 3 divided by 2. Remember that here the midpoint of AC is same as midpoint of BD. What do you say about this? This is true for only parallelogram. So therefore, the diagonals bisect each other. Hence, the figure is a parallelogram. Next, I shall give you many problems pertaining to that. Which of the following maps are linear transformation? So therefore, I have given various problems here. First, you have to check whether they are linear transformation. That is, you have to check whether the two conditions of linear transformation. Next part is second one, that is find a linear transformation same as this. And I worked many problems on this. You go through this and you work these problems. How to check the answer here? Given vector substitute ಮಾಡೋದ್ರಿಂದ ನೀವು ಆನ್ಸರ್ ಅನ್ನ ಚೆಕ್ ಮಾಡಬಹುದು. ಅಂದ್ರೆ t of 1, 2 ಕೊಟ್ಟಾಗ ಇಲ್ಲಿ 3, 0 ಬರಬೇಕು. t of 2, 1 ಕೊಟ್ಟಾಗ 1, 2 ಬರಬೇಕು. ಅದು ಕೊನೆಗೆ ಆನ್ಸರ್ ಬಂದಾಗ x ಗೆ 1, y ಗೆ 2 ಕೊಟ್ಟಾಗ ರೈಟ್ ಸೈಡ್ ಅಲ್ಲಿ 3, 0 ಬರಬೇಕು. x ಗೆ 2, y ಗೆ 1 ಕೊಟ್ಟಾಗ 1, 2 ಬರಬೇಕು. ಆವಾಗ ನೀವು ಮಾಡಿರೋ ಸರಿ ಇದೆಯಾ ಇಲ್ಲೋ ಅನ್ನೋದು ಗೊತ್ತಾಗುತ್ತೆ. So Zoom time is running out now. So I shall close this meeting. something there is in the chart. 5/2 ಹೇಗೆ ಬಂತು ಅಂತ ಒಂದಿದೆ. ಎಲ್ಲಿ 5/2 ಅನ್ನೋದನ್ನ ಫಸ್ಟ್ ಐ ಶುಡ್ ಲುಕ್ ಇನ್ ಟು ದಟ್. ಸಂಬಡಿ ಆಸ್ 5/2 ಹೇಗೆ ಬಂತು ಅಂತ ಅಲ್ವಾ. 5/2 ಟ್ರಯಲ್ ಅಂಡ್ ಎರರ್. ಟ್ರಯಲ್ ಅಂಡ್ ಎರರ್ ಅಂದ್ರೆ 2/2ನ 5/2 ನಲ್ಲಿ ಬರೀರಿ ಅಂದ್ರೆ ಬರೆಯೋದು ಹೇಗೆ. 5,5 ಅನ್ನು 5/2 ಇಂಟು 2,2 ಅಂತ ಬರೆದ್ರೆ 5,5 ಬರುತ್ತೆ. 5/2 ತಗೊಳ್ಳೋದು ಹೇಗೆ ಅಂತ ಅವರಲ್ಲಿ ಡೌಟ್ ಇರ್ಬೋದು ಅಂತ ನನ್ನ ಅಂಬೋಣ. ಇರ್ಲಿ, ಅದನ್ನ 5/2 ಬರೆಯೋದು ಹೇಗೆ ಅಂದ್ರೆ ಬೈ ಟ್ರಯಲ್ ಅಂಡ್ ಎರರ್ ಮೆಥಡ್. ಅಂದ್ರೆ 2,2 ಒಂದ್ ಕಡೆ ಬರ್ಕೊಬಿಡಿ, ಅದರ ಪಕ್ಕದಲ್ಲಿ ಯಾವುದರಿಂದ ಗುಣಿಸಿದ್ರೆ 5,5 ಬರುತ್ತೆ ಅಂತ ಅಂದಾಜು ಹಾಕೋದು. ಅಗೇನ್ ಇಟ್ಸ್ ಅನ್ ಅಪ್ರಾಕ್ಸಿಮೇಷನ್. ಅಂದ್ರೆ ನೀವು ಅಂದಾಜು ಹಾಕೋದು ಬಿಟ್ರೆ ಬೇರೆ ಮಾರ್ಗ ಇಲ್ಲ. ಅಕಸ್ಮಾತ್ ಬೇಕೇ ಬೇಕು ಅನ್ನಿ ಅದನ್ನೊಂದು ಸೊಲ್ಯೂಷನ್ ಬೇಕಾದ್ರೂ ಮಾಡ್ಬೋದು. ಹೇಗೆ? 5/2 ಬರೀಲೇಬೇಡಿ, C1 ಬರ್ಕೊಳ್ಳಿ. C1 ಅಂತ ಬರ್ದ್ಬಿಡಿ. 5 ನಾನು ಹೇಳ್ತಾ ಹೋಗ್ತೇನೆ, ನೀವು ಬರ್ಕೊಳ್ಳಿ ಈಗ ಬೇಕಾದ್ರೆ. 5,5 ಈಕ್ವಲ್ಸ್ C1 ಇಂಟು 2,2 ಅಂತ ಬರ್ಕೊಳ್ಳಿ ಫಸ್ಟ್. 5,5 ಈಕ್ವಲ್ಸ್ C1 ಇಂಟು 2,2 ಬರ್ಕೊಳ್ಳಿ. ಆವಾಗ ಅದನ್ನ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಕಾಂಪೋನೆಂಟ್ಸ್ ಅನ್ನ ಈಕ್ವೇಟ್ ಮಾಡಿ. ಈಗ C1 ಇನ್ಸೈಡ್ ತಗೊಂಡು 2C1 ಈಕ್ವಲ್ಸ್ 5 ಆಯ್ತು. 2C1 ಈಕ್ವಲ್ಸ್ 5 ಆಯ್ತು. C1 ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು? ಅವಾಗ 2C1 ಈಕ್ವಲ್ಸ್ 5 ಆಯ್ತು. C1 ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು? 5/2 ಸಿಕ್ತಲ್ಲ. 5/2 ಹೇಗೆ ಬಂತು ಅಂತ. ಸೊ ಐ ಹೋಪ್ ಯು ಹ್ಯಾವ್ ಅಂಡರ್ಸ್ಟುಡ್ ದಿಸ್. ಐ ಡೋಂಟ್ ನೋ, ಅಕ್ಷತಾ, will you please
Yes, sir.
Could you understand this now?
Sir.
ಇಲ್ಲದ್ರೆ ಇನ್ನೊಮ್ಮೆ ಹೇಳ್ತೇನೆ, ಗೊತ್ತಾಯ್ತಾ?
ಗೊತ್ತಾಯ್ತು sir.
Okay, right. Thank you. Zoom time is running out and I shall close this meeting for the time being. Right. Thank you one and all.